Welcome to practice problem 8.14, where you're trying to determine the delta H of this reaction. One of the things that we can note is that whenever we're looking for delta H of the reaction, and we can use the bond enthalpies, then we can turn to this equation which really just says that the delta H of the reaction is equal to the sum of the bond enthalpies of bonds broken minus the sum of all the bond enthalpies of bonds formed. And we can get these bond enthalpies from the table that's given to you. And so the first thing that we have to do is really think about what bonds are being broken and what bonds are being formed. So I like to just look at overall the structure, and so here we can start with ethane, where basically we have these two carbons which are connected by a number of hydrogens. And think about all the bonds that are being broken. So here we have a carbon-hydrogen bond. We have another carbon-hydrogen bond here. We have another carbon-hydrogen bond here. We have another carbon-hydrogen bond here, another carbon-hydrogen, another carbon-hydrogen. That's a total of 6 carbon-hydrogen bonds. But again, remember that this tells us a stoichiometry, which means there are 2 of those. So 2 of these whole molecules. And so really what it tells us is that we have a total of 12 carbon-hydrogen bonds in that molecule. But we also have a carbon-carbon bond here in between. And so we actually have 2 of those because, again, the stoichiometry. So we have 2 carbon-carbon bonds. Well, we then can move on to the next compound, which is O2, which O2 would be an oxygen double bound to another oxygen. And in that case, it tells us that we have 7 of those. So we have 7 oxygen double bond oxygen bonds. Those are all the bond enthalpies of all the bonds that are breaking. So we can imagine that we're breaking every single bond, and then we're going to connect all these back together and form new bonds. So we move to the products, and we see that we have a carbon-oxygen bond, and we have another carbon-oxygen bond, both double bonds. And so this C double bond O bond is breaking, where each molecule has 2 of those, and so it's a total of 8. And then we have H2O, where we have this oxygen-hydrogen bond and another oxygen-hydrogen bond. Again, there's 2 in each molecule. There's a total of 6 molecules, which means that we have 12 OH bonds. Now we can plug these into our formula, where we're looking for delta H of the reaction, and we're going to take all the sum of the bond enthalpies of the bonds broken. So we just start and say, okay, well, we'll start with carbon-hydrogen, where we have 12 of those. We look up on our table the bond enthalpy of a carbon-hydrogen single bond, and that is 413 kilojoules per mole. Plus, we look at the next bond, which we have a carbon-carbon. We have 2 of those, and each one of those is 348 kilojoules per mole. And then we look at the oxygen double bond to an oxygen. There's 7 of those, and those are 495 kilojoules per mole. That is all of the bond enthalpies of the bonds that are being broken. We're then subtracting that from all the bond enthalpies of the bonds formed. Well, we have 8 carbon-oxygen double bonds. Each one of these is 799 kilojoules per mole. Plus, we have this 12 oxygen-hydrogen bonds, which each one of these are 463 kilojoules per mole. And then we can add this up. And so what we end up with is a delta H of the reaction, which is equal to minus 2,831 kilojoules. All the moles cancel out because every time we say that we have 12 of these, this is 12 moles of the carbon-hydrogen bond. So we're left with kilojoules. This is the answer for the problem.